All right, so this video is about graphing inequalities, and this is lesson 50 in your book. So we're going to be talking about linear equalities in one variable. Now that means there's only one variable in our inequality. Eventually we'll get to two, but we're not quite there yet. Now, unlike equations, inequalities can have more than one numeric solution, meaning more than one number can make an inequality true. So if you think about if we're looking for a number that's less than 40, there are actually lots and lots of numbers that are less than 40, pretty much 39.99999. Anything less than that is going to be less than 40. So they have more than one solution. Their solution is actually a solution set. Now, to identify a solution of an inequality in one variable, we have to sub in numbers and then simplify to see if they make the inequality true. And that's what we're going to do with our first example. So example 1 here needs to be in your notebook. We need to determine which of these four values, 0, 2, 4, and 6, are part of the solution set of the inequality 4y minus 5 is greater than or equal to 11. Now what we're going to have to do here is take each of these values and sub them into our inequality for y, simplify them, and see if it makes the inequality true. So we'll start with 0. I'm going to sub 0 in for y. So I have 4 times 0 minus 5 is greater than or equal to 11. Now I do order of operations, so I multiply first. 0 minus 5 is greater than or equal to 11. 0 minus 5 is negative 5. Now, is negative 5 greater than or equal to 11? No. Negative 5 is less than 11. So we know 0 does not make that inequality true. Now we're going to try 2. So again, I'm going to sub 2 into my inequality for y. 4 times 2 minus 5 is greater than or equal to 11. And then I'm going to simplify. 4 times 2 is 8. So now I have 8 minus 5. And then 8 minus 5 is 3. So now my inequality is 3 is greater than or equal to 11. This is also not true. So 2 does not satisfy my inequality, so it is not part of the solution set. Now I'm going to try 4. Same thing, plug 4 in for y. So I have 4 times 4 minus 5 is greater than or equal to 11. 4 times 4 is 16. And 16 minus 5 is 11. So 11 is greater than or equal to 11 is true. So 4 is part of my solution set. Now I'll try 6. So I'm going to plug 6 in for y. So I have 4 times 6 minus 5 is greater than or equal to 11. 4 times 6 is 24. And then 24 minus 5 is 19. And since 19 is in fact greater than or equal to 11, 6 is also part of our solution set. So 0 and 2 not part of the solution set, but 4 and 6 are. All right, so sometimes we have equivalent inequalities, and these are inequalities that have the same solution set. Now, here we have x is greater than 0. So see how we have an open circle here? That means that 0 cannot be included. 0 is not greater than 0, so it doesn't work in this inequality. And our arrow is going to the right because we want the numbers that are greater. Here we have x is less than 0. So we have this circle on 0, and it's an open circle because that open circle shows us that 0 cannot be included in the solution to this inequality, meaning 0 is not less than 0. And our arrow is going to the left because these numbers that we want are less than 0, which is the number where our circle is. Here we have x does not equal 0. So we have an open circle here, which means 0 cannot be included. If we plug 0 in for x, we'd have 0 does not equal 0, which is not true. However, every other number does not equal 0, so our arrow is going in both directions. Right here, we have x is less than or equal to 0. Now, here, our circle on 0 is closed. That means that 0 can be included in our solution set. We can plug 0 in for x, and we'd have 0 is less than or equal to 0, which is true. And our arrow is going to the left because we want to include the numbers that are less than or equal to 0. So we want to go to the left because that's where the numbers are smaller. And then finally, we have x is greater than or equal to 0. So we have our circle on 0, because that's the number in our inequality. And it's a closed circle, which means that 0 can be included in the solution set. And our arrow goes to the right because the numbers we're looking for are bigger than 0. And those on the right of 0 are bigger. So basically what this is telling you is when you graph an inequality, you put a circle on the number in the inequality. In this case, the number was all 0. However, if the number had been 2, we would have put the circle on 2, or if it had been -1, we would have put the circle on -1. Now, whether the circle is open or closed depends on the equal sign. If there is not an equal sign underneath, then you use an open circle, and the same is true with does not equal, because it means it can't equal that. However, if there's an equal sign included in your inequality, then you put a closed circle showing that that number can also be included in the solution set. Now we're going to try some of those. We're going to graph each of these inequalities on a number line. Our first example here is g is greater than 5.8. So I need to write a number line that includes 5.8 because that's the number in my inequality. So here's what I'm going to do. I'm going to make this 5.8, and I think I'll make this 6.0, and then we'll do 6.2. Notice I'm going up by 0.2 every time, so I'm going to go down by 0.2 every time. 5.6, 5.4. Now you could have done like 5.8, 6.8, 7.8, and then like 4.8, 3.8 if you wanted. But all of these marks have to be equally distant. If they're equidistant, they have to be equally far apart numerically. So the difference between each of these is 0.2. If I had done it the other way, it would have been 1. Now, the number in my inequality is 5.8, so I know I need a circle on 5.8 right there. Now I have to decide, is that circle going to stay open or is it going to be closed? If I plug 5.8 in for g, then I'm going to get 5.8 is greater than 5.8. Now that is not true, so I'm going to leave this circle open. Now the numbers I'm looking for need to be bigger than 5.8, greater than 5.8. So I'm going to point my arrow in the direction of the numbers that are larger than 5.8. So 6.0 is bigger, 6.2 is bigger. So my arrow is going to go in this direction. And there I've graphed g is greater than 5.8. The next one is v is greater than or equal to 6. So now I need a number line that includes 6. I always like to put 6 in the middle. You don't have to. Or, I mean, the number in the inequality in the middle. Okay, so now I've got a number line that includes 6. All my numbers are equidistant and they're equally differenced. Now I need to put a circle on 6 because that's the number in my inequality. And now I need to decide, can I close that circle or do I need to leave it open? So if I plug 6 in for v, I get 6 is greater than or equal to 6. That is true, so I fill in the circle. Now, my variable needs to be bigger than 6. So I need to point my arrow in the